Venus is Earth's sister planet and our closest planetary neighbor. And moving southward, viewing a 25-kilometer-wide swath to about 68 degrees south latitude.
In 1991, Magellan arrived, started taking pictures and sending them back to Earth.
The orbit strips that it returns are about 20 kilometers wide and about 10,000 kilometers long. What we do here on the ground is we take these strips that Magellan gives back. Every day it gives back about 7 of these strips. We take these strips and we put them together into a mosaic such that you aren't looking at through a picket fence, let's say, at just one small piece of it. So on the ground, we take the computer to come and put these swaths together. As you can see, here's one strip or swath, and here I purposely skipped one, and then here's the next one, which would be orbit 386. If we continue to put these orbits in the frame, you can start seeing a wider peripheral view of the planet. And as we fill it in, we see an impact crater on the surface.
As well as taking flat pictures of the surface, Magellan uses its radar to measure the height of the land underneath it. Computers put the 2 bits of information together and produce a real 3-dimensional picture of the planet's surface. Join them together and this is what you get.
Let's take a look at, for a minute, a global view of Earth and Earth's atmosphere. Now here we see there's quite a cloud cover on this particular day. Venus, on the other hand, has a very, very dense cloud cover. In fact, its atmosphere is 90 times as dense as Earth, and it has a greenhouse effect. The temperature at the surface of Venus is 900 degrees Fahrenheit.
Despite this, pictures from Magellan's radar show many Earth-like features. This is the tallest volcano in the solar system. It's over 3 kilometers high. The last 30 years has been the golden age of solar system exploration. Robot spacecraft have sent huge amounts of information back to Earth, and now Voyager has taken pictures of the outer planets. So what's next?
The time has come to look beyond brief encounters. We must commit ourselves anew to a sustained program of manned exploration of the solar system, and yes, the permanent settlement of space.
This is the Lunar Habitation Module mock-up, and we're right now at the workstation. It will accommodate 6 people, and we have 4 workstations that are shaped like cocoons, and they close and open as an eyelid would. As we come over next to, we find the health maintenance facility, and it's here for purposes of medical emergencies and surgeries, and just to monitor the crew health. And again, the bed is stored away to allow for circulation.
At the moment, most of this is science fiction. By the 21st century, it will be science fact. A cloudy island in the middle of the Pacific seems an odd place to put a telescope, but on the big island of Hawaii, there's a mountain 4,200 meters high, way above the clouds. Mauna Kea is the finest place on Earth to view the stars, and now the biggest telescope in the world is being built there. When it's finished, the Keck telescope will have a mirror 10 meters across. The mirror's only half finished now, but it's already been used.
We've taken some pictures of galaxies, and here we have two pictures of NGC 1232. This is a relatively nearby galaxy. It's about 100 million light years away. This was taken with a Keck telescope when we had 9 mirror segments in place, so this is a 5-meter telescope. This is only a 1-minute exposure, so here, with a 5-meter telescope in a minute, we've taken an excellent picture. The light we see from this galaxy left that galaxy 100 million years ago, and it is just now arriving here.
The larger the mirror, the more light it collects, and it's the mirror that makes this telescope special. It's made up of individual hexagonal mirror pieces all joined together. There will be 36 of them when it's finished. Each mirror piece has rods attached to the back that actually bend and change the shape of the glass under computer control. In this way, the shape of the whole mirror can be made very accurate indeed. If this 10-meter mirror were made out of solid glass, it would bend under its own weight and distort the pictures. The Keck telescope uses visible light. This telescope uses infrared light that we can't see. So what extra information can we get from infrared light?
This is an optical image of a region close to the center of the galaxy. It shows that there are several stars present, plus some faint nebulosity. This is gas and dust which is reflecting the light of these stars. It's thought to be the site of active star formation. This means that young stars are being formed out of the gas and dust in this region. We went then to our infrared telescope and took some infrared pictures. Infrared is the study of heat radiation, and infrared radiation can pass through the dust and gas which is obscuring the sources. The two stars here and here in the optical photograph are in fact the two stars here and here in our infrared picture. And between them we find a very bright and peculiar shaped region of nebulosity. To enhance the picture and get more information from it, we represent the different brightnesses by colors. In this case, black is the faintest and red is the brightest, with intermediate colors representing intermediate brightnesses. We see lots of different features appearing, like wisps of nebula up here and here, and lots of faint stars which stand out better against the background.